The goal of Lab 2 was to observe the motion of an object drop from rest and record the results, while keeping in mind that the objective of this lab was to look at the falling motion of an object, including key concepts such as velocity, acceleration, and drag force. I modeled this lab by using a stack of 2 paper cups and dropping them from roughly eye level. After recording this motion, I used Tracker to analyze the video, and now we will look at the Tracker video to better understand the movement of the cups. Here you can see the red dot signifying the center of mass of the paper cups as they fall to the ground. The graph to the right shows the position of the cups on the y-axis over time, and as you can see, the slope of the graph starts off getting steeper until the moment in time at t equals 0.4 seconds. Here, the slope of the velocity begins to lessen, hinting at the idea that the drag force could be increasing and the cup could have been approaching a terminal velocity. We define terminal velocity as when the velocity becomes constant because the acceleration is 0 because the drag force is equal to the weight. After using Tracker, I made a conceptual model in GlowScript that you can see here. For this, I used t and tmax to represent the time in my experiment, where tmax is how long it took the object to fall to the floor. Other important stats include the initial velocity of 0 at time 0, the initial position at time 0 of 2.29 meters above the x-axis, and the mass of the ball. I then created a loop in the code so that it looped in increments of 0.001 seconds, capturing each new velocity at a new time to track the object's velocity downwards as it fell. The graphs on the screen compare the difference in velocity from the experiment, the model I created, and an object in freefall without drag force. You can see that the model and experiment both almost stop increasing, which makes us believe that they have approached a terminal velocity, where the object in freefall with no drag force continues to have its velocity increase as time goes on. What does it mean? By examining the velocity versus time graphs, it is evident that the models with drag have a terminal velocity. By definition, terminal velocity is the speed that an object in freefall reaches once it has stopped accelerating because of a resistance or drag force. Therefore, the models with no drag have no terminal velocity, and they will keep accelerating downwards until they hit the ground. To answer the what-if question, we look at 2 identical objects, one with an initial downward force. Here, the one not starting from rest would have a different terminal velocity because drag force is dependent on the speed of an object. Therefore, the terminal velocity of an object with an initial velocity is greater than one starting from rest.